So hi everyone. In this video, we're trying to contribute to an open source organization that comes to GSoc pretty frequently. And I'm trying to create a series where I'll just pick a project up and we'll do 4 things with it. Number 1, we look at all the existing GSoc projects and some future projects that this organization might have. Number 2, we'll try to set up the code of this organization locally. Number 3, we'll try to make an open source contribution. Number 4, I'll link a few issues and tricks and tips as to how you can solve some issues yourself. Few disclaimers, please be very polite when you're trying to make an open source contribution, and you have a lot of time, 6 to 8 months right now. So go slow and steadily, understand the code base, and then maybe contribute when you're very comfortable with it. All right. That let's get right into it. The organization for today is called the Processing Organization. It's been coming in GSoc for around 12 years now. In fact, this is one of the organizations that I contributed to back in college. The year that I was contributing to processing, they did not make it to GSoc, but luckily for me, they were my backup organization. My primary organization that year was Mozilla. Generally, I've seen the trend that processing is extremely active in GSoc, so there's a good probability that they come into GSoc next year as well. Let's try to understand what they do and look at a bunch of their code base. All right. So this is the processing organization. They have a bunch of small projects. The ones that we'll be focusing on is this one called p5.js and a bunch of auxiliary libraries. They have p5.js is sort of, if you've heard of 3JS, it's like similar framework that lets you do things like creating games and a bunch of animations. Basically makes it easier for you to do visualizations. And you can use it in not just the web using p5.js, you can use it in Android. They have the same sort of functions that in Python, so you can create a Python game. And their, I think, original implementation was in Java. I could be wrong. This processing native application was written in Java and was the first implementation of processing. And then they've ported this implementation into various languages, one of them being p5.js, the one that we'll try to contribute to today. So let's look at a few projects from processing last year. If we look at the ideas list from last year and a bunch of projects that were chosen, improving p5.js. So this is in the library that we'll try to contribute to. Write friendly error systems and documentation, most probably might be the same project, p5.js. Let's see. Yep, looks like it's in p5.js. Mobile and responsive design implementation of p5.js web editor. So this is not in the p5.js project most probably, but in this project, the p5.js web editor. Alrighty. So luckily, thankfully, there were definitely a few projects in, oh wow. Migrating VR library and adding images and markers to AR. I don't know which project this was in. Let's see. But seemed like a pretty sort of hefty project to do. I could be wrong. I mean, just looking at the name, it feels fairly hefty. Can't find the code. All right. Let's move on. p5.js, p5.js.org, site documentation and accessibility. All right. That might be a different, oh wow, project. Let's see. So basically I found like, oh, there you go. So basically I found a lot of projects in the p5.js ecosystem. As I said, they have a few projects, processing in Java, processing in Python, Android, but p5.js is the sort of common one when it comes to Google Summer of Code. They usually have a bunch of projects in them. All right. There's also a very nice project list that they have. This page contains the ideas of how you can contribute to processing foundations work on processing p5.js, so on and so forth. Let's look at a bunch of. So as you can see, they came to GSoc in 2022, 21, 20, 19, 18, 17. They also came in 2023. I think somewhere here, they took a break, which is when I applied. But let's see. As you can see, there are a bunch of ideas here already. For example, expanding p5.js accessible outputs. So as you can see, it says, we would like to build upon the current accessibility infrastructure, which I think usually means to help the visually impaired or people who cannot hear well navigate through a website. Let's look at a bunch of other projects. There are a bunch of high priority ones, although these feel like you'd have to understand their core rendering logic a little bit. Let's see if there's something more. There are a bunch of projects in p5.js web editor. I think this is the one that we just saw that came in GSoc last year. One very simple one to knock out of the park that I can see is internationalization and localization in the p5.js web editor. So maybe let's go to this project and try to contribute to it today. So as I said, this is step 3 where we're trying to contribute. They have a bunch of projects that you can contribute to. The one that we're contributing to today is p5.js web editor. This is what the code looks like. Let's try to dive deeper into understanding how they've built the thing that they've built here. All right. So p5.js web editor is a website for creating p5.js sketches. So before that, let me give some context as to what p5.js is. Back in the day, it used to be a library that lets you do things like creating games, animations, things like these. So if you look at their API, let's look at a simple p5.js example. There you go. Clock. So as you can see, this clock has sort of been written using the p5.js library, and all the animations that you see, the tick sort of moving around, happens through this code, and this code sort of interpreted by the p5.js library. So if you have p5.js library in your project, like your HTML file, and you've written all this JavaScript code, it will be able to create something like this. Let's look at a basic example, and let's try to run it maybe locally or on Replit. So there you go. This is sort of a square that moves around based on where my mouse pointer is, I think. All right, let's look at the code. What does it say? There is a draw function that sets the background to this gray color. And if second mod 2 equal to 0 during every even numbered second, so 0, 2, 4, so on and so forth, angle equal to angle plus jitter, some maths they do that actually makes this guy rotate. So you as the application developer just have to write this much logic, and the p5.js library will sort of take care of rendering this square on a canvas. And this can be extended to adding lights, more physics, creating a ball that has gravity, so on and so forth. It's a very nice sort of animation engine if you're trying to create games or things like these. The thing that we're contributing to, however, is much simpler. It's this thing called the p5.js editor, which is a website similar to Replit, where you can go write some processing code, which is basically code like this, and then see your output on the right hand side. So first step, let's try to set this project up locally. That's the most important thing. First step there is trying to clone the project. So let's do that. I'm going to copy this. You should as well. So let's open a terminal and try to clone this project. Alright, I've brought this project code locally. What that means is whatever code you saw here in the project now exists on my machine, and I've opened it in an IDE of my choice. The next step usually is to set up the project locally so you can make some changes and see that your changes are actually fixing the issues. Let's do that next. Let's look at their docs and what they say. The editor is focused, the p5.js editor is a website for creating p5.js sketches. What are p5.js sketches? This thing right here. With a focus on making code accessible and inclusive for artists, designers, educators, beginners, and anyone else. So it's basically, we'll see what it is when we set this up very soon. Community, get started, make your first sketch here. So this is sort of the final website that we'll be able to set up locally. The code for this website, editor.p5js.org, exists in this repository right here, and I'm trying to run it locally. So I can make some changes to this code and be able to see those changes locally. Whenever I push my changes to GitHub and they deploy it to editor.p5js.org is when I will officially have made an open source contribution. All right, let's look at the setting up procedure. Refer to this documentation for setting up your environment. Let's click there. Manual installation, Docker installation. So there are two things you can do here. For those of you who don't understand Docker sort of lets you create this thing called a container and run all the code inside it so that your machine does not install a bunch of dependencies that you then have to get rid of after you lose the project or think of deleting the project. So it's generally a good idea, at least when you're starting out, to run the project locally. When you create a Docker container, from a very high level, understand this. When you create a Docker container, it self-installs all the dependencies that you need and the right versions of it, versus if you're trying to set this up locally, you have to be on the you have to install all the libraries in your local machine and then go from there, which sort of becomes hard. So it's generally a good idea that when you're starting to contribute and bringing the project up locally, use Docker so your machine doesn't get bloated with dependencies that you might not need in the future. All right. What's the procedure there? One thing you need to make sure is you have Docker and you have Docker Compose installed. Very simple steps to follow. Go to the Docker website, just Google Docker, install Ubuntu, Mac, so on and so forth, and the other thing you have to install is Docker Compose. Once you've installed both these things, you should be able to simply run this command that will sort of bring your container up and start the website basically. How this runs under the hood is basically, if you look at this docker-compose-development.yaml, this basically has all the code to basically describes, okay, bring up MongoDB locally, because that's the database that they use. So if you look at this file from the very high level, it says bring MongoDB up locally. How does it do that? Basically says there's this MongoDB image somewhere on the internet that someone has posted. Just bring this up locally and start this in a container. Secondly, start an application in the container. The code of how to start it or what all dependencies to install to start it exists in this thing called the Docker file. All right, let me give you a very high level of what Docker is. So this is your machine, and usually I have my code in this projects / whatever p5-editor folder. And usually before Docker was introduced, the way you would run this is you would bring Node.js, npm, whatever database you're using, let's say MongoDB, on your machine, run them independently. So run a MongoDB instance independently here in your machine, and then bring Node to your machine, bring npm to your machine, and then after you got rid of the project, you still have MongoDB, you have to find it and delete it, same for Node and npm. It brings a bunch of external dependencies that you may or may not need in the future into your machine. Question is, how does it happen when you're using Docker? And the answer is, if this is your machine, everything comes inside this thing called the Docker container. And whenever you get rid of the Docker container, you get rid of all the dependencies that you brought in. So we will get all these dependencies in this case as well, because the project sort of needs Node, npm, and MongoDB, but they all get installed in a mini computer, you could say, inside your big Mac computer. So if this is your Mac computer, there is a mini computer running inside. Inside this mini computer, you run Node, install Node, npm, and MongoDB. You run MongoDB, and whenever you want to get rid of it, you just kill the mini computer, and all the dependencies, all the things that you brought in sort of go away. That's the high level benefit of using Docker when you're trying to set the project up locally. The second good thing is you have to run a single command, and there is a very long Docker file that contains what all is needed and what all needs to be installed to create this mini machine, versus if you're going down this route, then you're manually installing Node, installing MongoDB, starting MongoDB, all that jazz, versus in this case, you run a single command and there are a bunch of files where you've clearly written, okay, this is how you get MongoDB, this is how you get Node, this is how you get npm, and then Docker does its thing and gets the project up here in the Docker container. All right, let's quickly look at the Docker files and I'll explain a little bit what those are. Then let's just start the project locally and start contributing to it. So there are two important files here. One is this file, the docker-compose-development.yaml. It says what all Docker containers you need to run locally, and in our case the answer is we need 2 Docker containers running locally. One that should start a MongoDB instance on our machine, 2 that should start our main application, which is the front end and back end of our p5.js editor, this website right here. How does it know where to install it from? The answer is this thing right here. Image Mongo 4.4 is basically a Docker, what's called image, that's present in this thing called the Docker Hub. Basically, someone got all the code of MongoDB, compiled it very well and pushed it somewhere on a place called the Docker Hub. And here we say, bro, pick MongoDB from Docker Hub and start it in this container. Secondly, start an app in the container, and all the logic, all the code for that specific container is in this Docker file. It's not in Docker Hub. That specific code isn't yet deployed to Docker Hub. It's present locally in my machine. You should pick all the code for the main application from this Docker file. So if I go to this Docker file, if I look at it, it basically has a bunch of verbose code that says, okay, this specific application needs to run on Node.js version 16.14.2. So it basically gets a base Node image from Docker Hub, this thing right here. So if I go to Docker Hub, I can see a Node Docker image. It gets the specific version of Node there. This again has been created by a bunch of maintainers. And inside this container that already has Node installed, specifically this version of Node installed, it does a bunch of things. The important things it does is builds the project, copies the client, copies the server, and runs npm start. So all these commands that you would have had to run locally on your machine are now running inside a Docker container. And this file contains all the logic that will run inside the Docker container. so that when you go to this docker compose.yaml, it knows what to do when it starts the Docker container. We will see this very soon. All right. So let's do a quick recap of what Docker is and how it's used. When you're setting up a project locally using Docker, there is usually just one file that's important, the Docker file. In our case, that Docker file looks something like this. It has all the code that's written that in the pre-Docker days, I would have had to run locally on my machine. So in the pre-Docker days, I would have first had to install Node.js on my machine. Once I would have installed Node.js, I would have had to run npm install in that project. After I would have run npm install, I would have had to run npm rebuild node sas. Then I would have had to run npm start to start the project locally. If you want to start it locally without Docker, you can actually follow these steps and it will run without using Docker. In fact, if I go here to p5.js web editor, and if I go to this documentation for setting up, the manual install actually looks something like this. It says install Node.js, which is similar to the first thing that's happening here inside the Docker file. Install Node.js. After you clone the repo, what does it tell you to do? It says npm install. That's exactly what's happening here in this step. So all of these commands have been written in a long file, and you can just use this file to start the project up locally. In our case, we need two things. We need the project running. We also need MongoDB running, which is why we create the compose file, which lets you run multiple Docker containers together. And that's this file right here. So here we say, okay, run a MongoDB image. I also have MongoDB running locally, and I don't have to bring MongoDB to my machine and start in a different terminal. This will start MongoDB in a container. Cool. High level of what Docker is and how it's used to start a project. If you don't understand it, it's fine. You can either do the manual installation, or you can simply use Docker to start the project up locally. You don't have to understand how it works locally yet. All right, cool. All right, so the way to run it locally is usually there is a default Docker compose file, which is this file right here. This has almost the same things, only this is meant for production. We are running it locally, so we are going to use Docker compose development. The way to run the Docker compose development file is docker-compose -f docker-compose-development.yaml up. What will this do? This will go into this file, understand the containers that it needs to bring up, and that's what it's trying to create here. So as you can see, it says container MongoDB running and container p5.js web editor recreate. Let's wait for it to start the container and then we'll proceed. So as you can see, it started two containers, the MongoDB container which is running, and then the p5.js web editor container. Again, where does this come from? This comes from Docker Hub and starts MongoDB locally. Where does this come from? This picks up the files from this project and starts them in a Docker container. Where have I written all of this logic? I have written all of this logic, well, the developers have written all that logic here in this top level Docker file. So to start this second p5.js web editor container, this was the file that was looked at, and all these commands were run inside a container. If I stop this, what will happen is both the containers will go down, and then I have to do some cleanup, but it was very easy for me to start in a single command and then stop everything in a single command. That's the benefit of using Docker. All right, let's bring it up again. Before you do that, if you go through the README, it will tell you to do one more thing, which is they have a top level .env.example file. It looks something like this. And you need to copy this over into the .env file and replace the right set of credentials. In our case, we don't have to replace anything because we're running it locally. But let's say if you were running MongoDB on the cloud somewhere, then you would have had to replace the MongoDB URL, for example, here with your cloud MongoDB instance. So this is the file that is usually changed when you copy your code over to production. It contains all your configuration logic as to what DB to connect to, what is the credentials for another backend service, what is the credentials for example, for Mailgun to send out emails, so on and so forth. In our case, when we're running it locally, you don't have to make any changes. All you have to do is copy over .env.example to .env, and then you're good to go. So Docker compose up with the right file here. And now if I wait for some time, it should start frontend and backend for me locally. And I think the port that it starts it on is let's see, either 8000 or 8002. All right, so as you can see, I have the p5.js web editor running locally. It shows me the state here on the right. This is development mode, which is why I see this. When we run it in production, this sidebar sort of hides away. This is just for debugging purposes because it lets you see the state of the application very well. As you can see here, it's basically sort of an editor similar to Replit. It lets you write p5.js code on the left, and then you can see the preview on the right. If I increase the height or the width of the canvas, you can see the changes being propagated here. Let me increase the width and then decrease the height to 100 maybe. Then as you can see, decrease the width, increase the height, and those changes are propagated here. So this is very similar to Replit, only you can write HTML, well specifically JavaScript code here on the left. You can create files, all that jazz. And this is the syntax to write an application using p5.js. This is the place where you can preview your changes. All right. If I try to bring an example from here, for example, this angle example, and paste it here, I should hopefully see the rectangle on the right. You don't see it completely, but you get the idea. You write p5.js code on the left, you see the output on the right. Now that we've brought the project up locally, let's try to make a contribution. Just to confirm that we have brought the project up locally, let's look for sketch files throughout our project. I see the string in multiple places. This is the one. If I replace it with sketch files 2222, I should hopefully see that change being propagated here if I refresh. As you can see, sketch files 2222. If I expand this, you'll see the whole thing, which means the project is running locally. Whatever changes I make here, they propagate here, which means, let's say one of the issue was, okay, change this title from sketch files to let's sketch something today. Then all you have to do is make the change here, save this, and then commit those changes, push them to the website, and then you're good to go. You've made your first open source contribution. But this is not a real issue, so let's try to look at a real issue and try to solve it. If I go to p5.js web editor, there are a bunch of open issues, which means things that you should fix. Let's try to understand. Let's try to look through a bunch of these and try to solve them. A few moments later, a few moments later, then I'll open the main issue. Okay, I think I found a beginner friendly issue, very nice first issue that you can solve. And even after I contribute, as you can see, there are a bunch of tasks. So I'll try to solve one task and then you can pick up the rest. Let's look at what it says. It says convert legacy React class components to functional components. It keeps the code base up to date and makes it easier for new contributors. So this issue is very similar to, let's say this project wanted to migrate to TypeScript. And when you do such a big migration, you migrate file by file. So you can basically break this down into a bunch of issues and convert JavaScript to TypeScript in various files. So this issue basically is similar to, let's say this project wanted to go from JavaScript to TypeScript. You don't make that issue sort of on day zero. You slowly move each and every file to TypeScript. So the goal here is, in the past, this project used class components. Now it wants to use functional components. It has migrated some components to the new format. All the new components that they write are written in the new format, but there are some that still exist in the old format. So we have to fix all of those and convert them over to a functional component. As you can see, they've created a bunch of tasks here. For example, the overlay component needs to be converted from a class-based component to the functional component. If I look at the fix, so this one was already fixed, the overlay one. The ones that have a checkbox here have already been fixed. The ones that don't still need some contributors to come and fix them. If you look at the overlay component fix change, if you go to overlay.jsx here, as you can see, so this used to be a class-based component before. Now it is a functional component. This is sort of the change that they made. If you don't yet understand React, this will be very weird. If you've done React only the modern way, then you understand this syntax. Okay, this is how you create components. You might not understand this syntax because this is how React used to be written a few years ago. The goal is very simple. Given such an old type of component, convert it into a new type of component. There are very subtle differences in how you used to write components before and after. Let me quickly explain them and then we can solve this issue. The high level difference was how you access props and how you access state in functional components versus class-based components. So the way to access sort of props is something like this in class-based components, where you had a constructor, you would receive the props in the component and then you would bind them to this here and then later use them. If you don't understand this, don't worry about it. Let me show you a class-based component right now. We will convert it to a functional component and then we'll try to see the difference between the two. Let's look at a class-based component here. For example, the search bar component. Let's go to our project locally and let's try to open the search bar.jsx file. So yeah, as you can see, this file has a class search bar extends react.component. As I said, this is how you used to write React components before, but today it's sort of changed. So as you can see, this is a class-based component. If you've written React anytime soon recently, this is the way you write React component function search bar, and then this returns whatever a div. But as you can see here, if you ignore all this logic above, rather than returning HTML, it sort of has a render function which returns HTML. And rather than having state variables defined here, for example, in functional components, this is how you usually define state variables: const search value, set search value equal to use state, whatever. The way to do that when you had class-based components was using something called the set state function. So you would call this dot set state with the state variables that you want to update, and then you would use those values, for example, sort of here. So the search value in this class-based component is a state variable, and this is how you would set search value in the old component stack. How do you set it today? This is how you define the state variable, and then this is how you sort of use the state variable, and this is how you update the state variable. Now that I think of it, this problem should actually be very easily solvable by an AI. Quite frankly, I can just copy this and maybe paste this to chat.openai.com, and it should be able to migrate it, which sort of tells you how easy it is to do these things today. Back in the day, it would require a lot of debugging, which I guess it will today as well if you're trying to solve this. But if I simply go here and say convert to functional component, please. Now the question is, Harkirat, should we do this? And the answer is, you can, if you understand everything. If you don't understand everything, then don't, because you might make an AI based change and then it will be very obvious it was an AI based change, and and if it's wrong, then it's sort of, you're doomed. And most probably developers, maintainers are slightly finicky if you're using AI to code, especially if you're checking in wrong code. So make sure you're able to understand the whole change. But I do feel this is a very simple thing for an AI to solve. So it should most probably do the change correctly, and then of course we will try to rectify it and make sure everything is working as expected. All right. It did give me the new component. As you can see, it's a function now, and it isn't a class-based component. And it does have the state variable values that I discussed initially. It converted, so let's try to go through this. At the top, it created the state variable, which is a state variable that this class-based component has as well. As you can see, this dot state equal to search value, this dot props dot search term, which means it is initialized with search terms that comes from the props. And as you can see here, we say search value is initialized with the search term which comes from the props. If you have not done React, this might feel a little weird, but hopefully if you've done React, this part is fairly straightforward. This part is legacy, so you don't need to understand it. It's not used anymore, but if you have to make such changes, then you need to understand it. Component will unmount, which means whenever this component gets unmounted, run this function. How do you do this today? You use an effect, and then you return inside the effect the function that you have to call when the component unmounts. So this part is similar to this part right here. Then they've defined a function here called handle reset search, and we have defined the same function here. This is the way you would define member functions before. This is how you define them now. Handle search change is this function right here. So the AI forgot one thing. It didn't define this search change function. This search change function isn't being used anywhere, so the AI did not sort of convert it, which is fine and actually pretty good. It decreases, well, a little bit it decreases the bundle size because there was an unused function here and the AI was smart enough to understand it. If you check this code in, the developer will be happy, or like the maintainer will be happy that you removed some unused code from the sort of component. Okay, this function, the same as this function, and then finally this thing would render it and we return the HTML, and then this is how you would use search value. You would get it from this dot state, and this is how we get search value now, which is simply defined here at the top as a state variable. So this mostly looks legit to me, although I would like to test it. So next, let's first try to revert all our changes in search bar. Let's try to look at it on the website and how it looks. Then we will replace it and make sure that it looks the same, works the same, and then we will try to check our code in. All right. How can I see this on the main website? There are a few ways I can see this guy's usage, how it's being used. Let's see, search bar. I don't see it being used anywhere. Okay, there you go. So collections.jsx uses the search bar component. Why does it use it? It simply exports it by connecting it to the state a little. So let's try to see if this collection component is used anywhere. and I do see it here. All right, let's copy this over and let's paste it maybe right here. So let's try to put the search component here so that we can see how it looked before. Then we will make it our changes and make sure it looks the same and works the same. The way to put it here is, first let's see where is the code that renders this thing. Okay, so it's actually sidebar.title. There you go. So this is the span that renders this thing right here. If I replace this with hi there, I hopefully see hi there here. It gives me a lint error. Let's do something like this. I see hi there here. Now if I put the component, I can actually just put the search bar component. Maybe let's put the component here. Sorry, the collection component, this thing right here, which internally uses the search bar component, the component that we're trying to change. If I save this and refresh, it gives me another lint error. Let's see. So we should use single quotes here. That's what it says. All right, save, refresh. There you go. And as you can see, in our sidebar, we now have a nice search component that sort of works as we expect it to. As you can see, this action sort of changes anytime I make a change here. We just need to make sure when we replace it with the new class-based components, the same thing happens. All right, time to yoink the code that we found on ChatGPT, replace searchbar.jsx with it, and see if it works. It gives me a bunch of lint errors. I cannot fix these by hand, so I'm hoping they have a script somewhere that lets me fix lint, and they do indeed. So all I have to do is run, hopefully, all I have to run is npm run lint fix, and it will, I have to do an npm install.
A few moments later.
I think I need to use a different version. All right, so one thing you have to do for this to work is you have to use the 16.14.2 version of Node.js. This is one of the benefits of Docker. Now that we're running the npm run lint fix command, we're running this project sort of locally without Docker, which is why I have to do all these things of downgrading my Node.js version, because this project only works with version 16 of Node.js. So one thing you have to do is downgrade the version of Node.js to 16 and then run npm run lint fix, and this should just fix your searchbar.jsx file, specifically like the spacings and all that jazz that they expect. Once that happens, you'll see that the file has been formatted correctly. If I now go to localhost :8000, if I go here, I see a very similar search bar, most probably, hopefully the same thing. And if I make changes here, I see them propagated here in state as well. So seems like this is working as expected. Again, let's try to push this to GitHub, try to create a pull request, and then let's try to compare what are the changes that we made and if things look right. All right. So if I do git status here and I try to first, check out to a new branch, fix dash side, not sidebar, fix search bar 1. And then here if I do a git add search bar.jsx, git commit dash m, moved search bar to be a functional component, and then fork the main repo. So if I go to p5.js web editor here, I can click on the fork button and it will fork the repository to my GitHub. I've already done this once. So if I go to github.com/hkirath/p5.js web editor, you see a fork of this project on my GitHub. If I now, the next thing I have to do is push my branch to this code. As you can see, I already pushed a branch a few minutes ago. The reason for this is the second time I'm shooting this part because the camera died. So let's now go back here and then add a new origin, git remote add origin 2, and then point it to my fork. Sorry, needs to be a space here. and then git push origin to head. That should push this branch over to my fork. And now if I refresh this, it should give me a way to create a pull request. So let me do that. So here is when I'm requesting the maintainers that I've made a change, please merge it. I most probably will not create it, so feel free to yoink this issue and then do it yourself. You have to sort of follow a few things. Make sure npm run lint works correctly for you locally. I think it will, because we just ran lint fix before this, which fixed all the lint issues. So if I run npm run lint, most probably it will work. Next thing it says is make sure the tests are running locally, so run npm run tests locally. Let me do that really quickly. So make sure whenever you're making this change, you do run these things locally, and then only if they succeed do you create a pull request. And here, as you can see, one test failed, and the reason for that is I sort of added this collection to the sidebar component, which shouldn't be the case. So let me remove that change. I only added that change for testing purposes, so to see the search bar in the sidebar, and the tests failed because they don't expect a search bar there. And as you can see, now if I run npm run test, it works, which means this works. The branch is uniquely named. It is uniquely named. It says hkirath/fix search bar 1, and then it is descriptively named and has an issue number. For example, it should say fixes the number of the issue, which in this case is this issue right here. Let's see, which was the issue? This one right here. So you should ideally put something like fixes this thing right here. Don't put this. When you put fixes issue number, and if this PR gets merged, this issue will get auto closed, but this issue has a bunch of things to fix, not just one. So even if this thing is merged, you should not close this issue. So maybe just write ref issue number rather than calling fixes issue number, because this does not fix the whole issue, it only fixes a part of the issue. All right, then create pull request and you're good to go. And I'm going to leave it as such. Let's just look at the changes one more time. What did we do? The search bar was defined as a React class-based component. We converted it to a function. Rather than getting props in the constructor, we get them here as arguments to the function. We have a state variable here. These guys had the state variable defined here in the class-based React component. This is how you do or like create state variables in a functional component. Component will unmount, which means whenever this unmounted, something had to run. We ran that using this use effect right here. Throttled search change is a variable which is the same as this variable right here that we have defined below. Handled search change was a function that we have defined here. Again, the syntax is slightly different and how you're using state variables is different. Here you did this dot set state. Here you would do set search value, and then finally this guy returns HTML. This guy used to return HTML inside a render function. This is how this guy used the state variable. This is how we use a state variable. That's the high level difference between class-based components and functional components. And then you can just replicate this to sort of other components that are mentioned in this issue. Again, I wouldn't use an AI if you're still learning. And secondly, if you do use an AI, please make sure you're rectifying all the issues correctly. Else, if something small gets missed and it's very obvious that an AI did that specific thing, if you have comments in there that seem very obviously written by an AI, it doesn't leave a very nice impression. So I would strongly urge for you to either fix it yourself. If you're using AI, make sure you rectify everything, make sure you test it locally, make sure tests are succeeding locally, lint is succeeding locally, and only then create a pull request. One issue I'm leaving you with is this one. Another issue I'm leaving you with is a slightly bigger issue, which is this issue right here, which says TypeScript support, which is this editor only supports JavaScript for now. Replit, as you might have known, like supports C++, Java, every language out there. So helping them add TypeScript support, which means so that the end users can come here and write TypeScript code and not just JavaScript code, would be a very impactful issue. Frankly, might just convert into a GSoc project, especially if you start to add Java support here, C++ support, all that jazz. So this is a good issue to solve so that you are able to pave path to a GSoc project in the future. That is what I would do if I was you right now. And there are some hints as to how you can succeed in doing this here. Might not be very straightforward, but I would at least try working on this issue in the next few months so that there is a path for me to contribute to a project that adds Java support, adds C++ support, as Python support to this web-based IDE. Because as I said, processing exists not just in JavaScript, it has a Python version, it has a Java version. So if you can bring that support to this web-based editor, that's super impactful, I think. So although that seems fairly difficult to now that I think of it, but either way, this is a pretty challenging issue. I would solve this next. However, this is a slightly difficult issue to solve. So maybe first try to solve a bunch of these and move a bunch of these over from class-based components to functional components. All right. It's a very long video, but hopefully it was helpful. Let me know what organization you want me to debug / understand the code base / solve an issue and set up locally in the next one, and then we can do that. I'll see you guys in the next one. Bye bye.